Hi everyone, welcome back to my video with me, Miss Devi. So today, in this video, we are going to learn about discriminant, and I think you're already familiar about this, right? So before that, I want to do a review. So let's do a review. Are you still remember about the formula of quadratic formula to find the solution of quadratic equation? Yes, I think so. So this is the formula of quadratic formula. x1 2 is equal minus b plus minus square root of b squared minus 4ac out of 2a. From this formula, contain the value of discriminant, which is b squared minus 4ac. So this, you can call it discriminant, or in Greek symbol, we can write d. Before we find out the definition of discriminant, let's check these graphs. Basically, there are three possible graphs in Cartesian coordinate. So for the first possibility, the graphs like this. So the first graphs have two intersections with the x-axis. This point and this point. And remember, intersection between graphs and axis will be the point. And the second possibility, the graphs like this. And this graph have one intersection with the x-axis, which is in this point. And this is the last possibility of the graphs. This graph doesn't have intersection with the x-axis. So for the first graph, that means the discriminant is greater than 0. That means have two distinct real roots. And the second, discriminant is equal with 0. That means double roots are two equal roots or twin roots. And the last, discriminant is less than 0. That means irrational roots or no real roots. And this is the table of the discriminant. For d greater than 0 or positive, have a quadratic equation have two solutions or different roots, and for the graphs of quadratic function, have an intersect with the x-axis at two different points. And for d is equal with 0, for the quadratic equation, have the solution or twin roots. And for the graphs of quadratic function, have intersects with the x-axis at one point. And the last, for d, is less than 0 or negative. That means the quadratic equation doesn't have any solution, and for the graph doesn't have intersect with the x-axis. To give you an idea about the discriminant, let's do an exercise. So this is the first question. Which one is the function which has two intersections with the x-axis? And I will give you some time to solve this question. So from the question, you get the hint that this function has two intersections with the x-axis. So it means d is greater than 0. So d is equal to b squared minus 4ac is greater than 0. So we can use this formula to solve the question. And now you have to try one by one of the option So for the first option, f of x is equal x squared plus 12x plus 36. So d is greater than 0, and we can do a substitution using this function, the first option. And we will get 0 is greater than 0. This is not the answer. So let's move to the next option. Fx is equal x squared plus 8x minus 20. D is greater than 0, and you can do a calculation. So it's equal 144 greater than 0. So this is the answer. So the answer is B. Is it easy, right? And for the next question, what is the value of P if the function f(x) is equal x squared plus p minus 3x plus p only have one solution? Now I will give you some time to solve this question. Now let's find the solution together. So from the question, you can get the hint. So this is the function. That this function only have one solution. And remember the relation between function and the solution. So we have to find discriminant is equal with 0. So discriminant b squared minus 4ac is equal with 0. And you can do a substitution using the function. And you can expand this quadratic. You can use a distributive law to expand this quadratic or this factor. And we'll get p squared minus 10p plus 9 is equals with 0. And we have to find the factor of this quadratic equation. Remember about how to find the factor. You can use any kind of way. So you can find a factor. P minus 9 times p minus 1 is equal with 0. So the value of p is 9, or p is equal 1. So the answer of this question is A. So that's all for our lesson today, and if you have any question, just ask me on the comment below. See you on the next video. Goodbye.